Speaking of reliability, a podcast with good friends talking with you about reliability engineering topics.
Welcome to Speaking of Reliability. This is Carl Carlson.
And this is Fred Schwenkelberg. Hey, Carl, good talking to you.
Hey, Fred. Yeah, just got an interesting reader question that I thought I'd talk over with you and see what your thoughts are. He's working in, just to say in a general, he's working in the EV, electric vehicle industry.
Okay.
And he wrote me about a type of FMEA called System FMEA, which is not in many of the standards. It's really a type of design FMEA, but I've always thought of it as a separate entity because it's dealing at the system level. And so he was writing about that, saying, is it real? Does it exist? And what is it exactly? And how deeply do you go, in the FMEA? Do you go down inside the components or what is the purpose of it and things like that? And I just thought that'd be fun to
It's an interesting question because I think I have two approaches and I don't know if either one of them is accurate. So although I did read your book and I read most of your articles, so I probably should know this the way you'd answer it.
Spot quiz.
Yeah. But one of them is early on when I thought of System FMEAs and ran across the reference to it somewhere along the line. It was probably one of your articles out of Reliasoft way back when. And I look at it more as a concept FMEA is before you've got all the circuit boards sorted out, all the materials designed and all the stuff all sorted out. It's a time to go, do you have the right features? Do you have the right sets of functional blocks that concept-wise, think of it as something you can do really early to identify, as we suspected, the power supply is going to be a problem. So we need to do a design FMEA on that block. We don't do design FMEA on everything. Let's do it on the ones that are new or different or troublesome or need improvement or whatever. But the concept or system FMEA was a technique to set up a cascading system of high priority things to further examine with FMEA and other tools. The second approach was it's a lot like a design FMEA, yet you're dealing with a bunch of black boxes. Here's the motherboard, here's the display, here's the power supply, here's the stuff, and what are the functional failure modes that are related to our requirements and everything else. And then you get down to, it's probably most likely due to the power supply. I just pick on power supply because it's sort of like picking on software, but different. And then that's an area for more focus. I've looked at it those two ways over the years. I have no idea if that's relevant.
I think you're very close on that, in my opinion, and you've got certainly the right concepts. The second one about black boxes, I think, is spot on. You don't want to go at a system level. You might have tens of thousands of components on a complex system. So there's no way a team is going to dive inside each of the black boxes if you're doing a large FMEA.
Well, I also think you should be doing this early enough that you don't have the details on everything yet.
Right, exactly. And so you're spot on there. The System FMEA would help you identify which black boxes need further development, or have a lot of risk to the system. And so you want to, as you design that black box, you want to understand what the risk is to the system, and so that the black box mitigates that. And so you're right, it's done early. In terms of concept, it has that flavor to it. There's also a type of FMEA called concept FMEA that can be done even before the system is identified. So and this is nothing official, that it isn't set in stone like that. Like there's no official standard or anything that says what a concept FMEA versus system. So this is really what works to make sure you've sifted out the risk.
Well, this all goes back. I mean, and I'm thinking about your book because there must be 40. I may be exaggerating by two or three different named FMEAs in there. When it comes down to, it's really about what is the scope of what you're trying to work on, what is the boundaries for your team, and it's if it's very very early, it's what are the hazards that we take this to market. It might be a business check. Is this something we can do or should do or it will have a market, or is this concept just impossible? And what are the areas that are we need miracles to happen for this to occur? And then but system could do that. I think there's a lot of overlap depending on that team's setting of the boundaries and scope.
Yeah, I think you raised the right point there, which is there's no particular value to having 15, 20 different types of FMEAs. That does not add value to. There's in the it might add familiarity. In other words, somebody can, okay, I've heard of that one or whatever.
Mm-hmm.
But what is important when we did our, I'll call it SA 1025, which is the team that we were talking about that's replacing the mill standard on FMEA.
Mm-hmm.
And that we distilled down to 4 types. And the reason there's 4 is because they're very different on deliverables. Okay. So one of them is design FMEA, and that's unique, but that can have different flavors like system, concept, but forget the flavors. For design FMEA, it covers the product design. Right. And then there's a manufacturing, what's called a process FMEA, and that covers manufacturing or assembly, or you could even do a business process. Mm-hmm. So there's different flavors of process FMEA. And then software is really a subset of design FMEA, but we called it a separate type because there's so much opportunity there. Yeah. And the software has different bodies of knowledge come into software. And then the 4th one is supportability or maintenance. And that is a very different because you get reliability centered maintenance and different supportability analyses that the supportability FMEA is input to. Yeah. So I'm going to agree with you that there's no particular value to having dozens of different types of FMEAs. You just really want to get what are the most important differences only when it adds value, like design versus process, that kind of thing.
No, I picked up on that in the book, and it was like, oh, okay, this is a slight variation to this slight variation to that. And it's really about the scope and the team you got together and the expertise to bring in the room. And
exactly.
And it doesn't really matter what it's called. I think it's setting the scope and boundaries, whether it's a concept or a system or a design, are we treating these as black boxes, or are we going down to the capacitor level? Or is this focused on, what I think you phrased it as what's the output of it, and that what action are you going to take based on it? And the other part of this that I mentioned a couple of times is that it's also timing. And I think what it really goes after when you have all of these different names to stuff, like a system FMEA, really only makes sense to do early in the program. And then as you learn more in design and process type stuff and developing your program and your software and everything else, is then are we still hitting the right high-end priorities? It gives you that high-level view in a system level that did we go down the wrong rabbit hole is kind of the way I think of it.
Yeah, I agree so those are the variables, and you're totally right that you want to get the scoping done. That's what defines, forget the word type, that defines what your FMEA is going to be.
Right.
And early on, you might do something at a system level because you have the system defined, you know what the system is. But later on, you're going to know what the black boxes are. And so you might do a design focused on the black box.
Yeah, and then
so yeah, it really doesn't matter whether you call what you call it. Wow. It's the scope and the ground rules and assumptions that go into the FMEA that matter.
Well, that down, and you have been battling this for decades, and I think I have been too, not as directly as you have, because you're in the committees and written extensively about it, is you don't start once you have the full bill of materials out and do it in every component and call it done. And they never touch it again. Like,
exactly.
Oh, good grief.
My
You're
God.
going to kill somebody spending it.
And some people are still doing that.
Yeah.
I mean, I just can't believe it. Not just some, a lot of people are still doing that.
Yeah.
They think an FMEA is a massive, one big giant reservoir of all the failure modes and the causes and the effects and an entire system going all the way down to the components.
Mm-hmm.
And no one has the time or the money to do that type of analysis in a timely manner.
Right.
If you had years and years, I'm sure you could do it, but product development has to be fast.
Well, it's also got to be useful. I've told you this story many times. I saw one I was teaching a class to a bunch of folks at the Navy's Nav Air, I think is what they abbreviated themselves out. And it was a bunch of reliability folks working on various aircraft and in the Navy's fleets and in their design and development and all kinds of other stuff like that. And one of the guys came back from lunch with this manila envelope that was a good 1.5 inches thick of paper. I had like a ream of paper in it. Oh, I just got the XYZ aircraft FMEA back. And I looked at it and go, what? How in the world is that actually useful? He said, well, and he hefted it and goes, well, it's not complete. I can tell it's not thick enough. That was his judgment of it.
Yeah. So let's parse this a little bit. I would rather have, in a complex system, I would rather have fewer FMEAs done well to get at the highest risk areas and make sure that high risk is addressed. The risk is acceptable in the system. I would much rather that than have tons and tons of FMEAs done poorly, which is often the trade-off.
Yeah. And this guy was going, well, it's a requirement. I have to double check that they did it. And he's like, are you going to read it? Oh, well, hell no, it's too long.
Yeah. Did he fill out the form? Did somebody fill out the form properly, thousands of pages?
Yeah. So hopefully my class helped them break that problem, but I can only hold my breath that it worked. It's like,
yeah.
They did invite me back the next year to teach again. So maybe there was some hope there.
So two reasons for a system FMEA different than maybe a black box FMEA. One, and we've touched on this, you did right away, which is in a system FMEA, you're not going deeply into the black boxes. So you're not, if you're doing a system FMEA on a vehicle, you're not going inside the tires or inside the seats or inside the pistons, that type of thing. You're staying at a higher level.
It would be stuff like the dashboard console and the steering linkages and system and the brake system and kind of at that level, I think of it as.
Yes. And there's a reason for that, because as you pointed out, you're in an earlier time frame, so you may not have that steering gear designed, so you don't know what material it's going to be or that type of thing necessarily. But you do know the concept. And so you're going to stay at that higher level. So there's a tremendous value of surfacing the risk at an early stage at a high level. The second reason for system FME, and this is what I shared with the gentleman who wrote the question, is the importance of interfaces. Because the black box, if you do a black box FMEA, you're not addressing the interface between black box number 1 and number 2.
Yeah, it usually stops right at where the connectors are. Where the tie rods or whatever, it's where the connections are. That's this at the edge of the box.
Right, at the edge of the box. And that is so critical, because every analysis I've done and every company I've worked with has shared with me that more than half the problems occur at the interfaces.
Yep.
And so if you're just focused on the black boxes, you're going to miss all kinds of issues.
Yeah, and it's not just connectors. It's stuff like timing between this system and that system says, I need 2 nanoseconds, but it can only physically happen in 8. That's an interface, or the type of code that's sent from one spot to another is, if it's not formatted correctly between the two, they don't work. If the voltage isn't right or stable enough between 2 boxes, then that's an interface problem.
Yes. Yes. And those are so critical. I like to make them visible in a FMEA block diagram, where you basically do a diagram of what your scope is. As you pointed out, you want to start with the scope.
Yep.
And so I identify the scope in a block diagram.
Well, that's often like a functional block diagram. Here's the braking system. There's a pedal, there's linkages, there's electronics, sometimes there's hydraulics, depending on your technology, there's all these different black boxes involved. But one has to talk to the other one in some way.
So we'll make that a line, that interface, we'll make that a line in the black box, and we'll make the boxes be those items. That line then becomes an interface, and we can trace the line to the FMEA. And so that line, which is essentially an interface, has a function.
Yep.
What does it do? It provides that 2-second delay that you're talking about, or provides some type of adhesion.
Or feedback, or something. Yeah.
And that function becomes part of the FMEA.
So what happens if you push the pedal and the linkage doesn't do an actuation of any kind? Well, that linkage is broken, not your foot.
Yeah,
not the hinge for the brake pedal.
Right. So those 2 reasons. One is you don't want to go in a system FMEA, you don't want to go too deeply. You want to stay at higher levels so you can guide and find the risk at the higher level, and then you can recommend the deeper dives at the component or even subsystem level.
In the box level. Yeah. The hard part I found in trying to do that is that you bring in the expertise, the right folks, somebody that's familiar with, say, the braking systems of a vehicle, or the batteries for an EV, or whatever. And it might not be decided what technology they're going to use, or maybe they're inventing a new one, say, for this braking system. And made me think of the first time brakes went to, or like an aircraft where they're flying by wire. I'll use that example. It used to be a physical linkage between the joystick and the ailerons and flaps and stuff like that. And then it turned into by wire. Can you imagine a bunch of mechanical engineers being the experts on controlling wing surfaces, doing that system FMEA?
Yeah, no, I can imagine it could happen. It wouldn't go very well. But as soon
as but I'm thinking of the issue is that you bring in people with expertise that are usually within the black boxes, whatever concept or feature that is keeping them out of that during the FMEA at the system level is a monumental test to a facilitator.
Exactly right. Precisely right, because the black box expert will want to dominate the conversation
or dive into
their particular needs.
Yeah, and that's only one of the problems for facilitation. Is the first one is that the first problem that gets surfaced, the engineers all go to the chalkboard, see how old I am now, and start working on a solution for it. And you're like, wait. we're just identifying the problems now.
So we're gonna do an FMEA with a team, and this is gonna bridge into other conversations that we're starting to have about artificial intelligence, but I'll save that for another podcast. But we're going to do the system FMEA with a team, and any FMEA with a team. But when you're doing interface A-B, so you got black box A next to black box B, interface AB, then you have to make sure you got the right people in the room.
Yeah.
So you want to have somebody that understands B, somebody that understands A, and somebody that understands the linkage between them, or the interface, or whatever that functional interface is. And that's part of the skill of a system FMEA, is getting the right people in the room, so no one person dominates.
Yeah, it's well, there's always challenges for facilitating and having system architects. The one one quick story, and we probably need to wrap it up, is I had went into one of them. This guy was the system architect. It's been, revered as the inventor of the whole product and all this other stuff. And his view of things was reminding me of a general when I was at an exercise in Germany, and he had the whole map of Europe up on the wall behind him. And he just kind of waved his arm, and we're going to go from here to here. And I'm looking at it, it's 600 miles. There's 15 rivers to cross. There's, all this terrain. And I'm thinking of, how do I get my vehicle to go there? He just waves his arm.
Yeah.
And some system engineers or some high level architects of systems are like that. Oh, well, that's in the details. So we'll figure that out. Sometimes that expert is a little bit too high.
Yes.
So it's a good test to get the right people in the room to have it goes back to what we started with. It really has to be scoped correctly.
Got to be scoped up. I'm going to add a 30-second story.
Okay.
And we can wrap up.
Sparked you there.
This is maybe 1 to 2 decades ago. I was called in to help with a large system. It was a tank, a large system. And the chief engineer holds a meeting, and this is to launch the System FMEA, holds a meeting, and he invites everybody that is in that system. And I stopped counting after it got to 35 people. And he says, okay, this is your FMEA team. And I said politely, we're going to break that into different teams.
Yeah.
And because you have even large subsystems. And so we broke it into a series of teams, including the interfaces. And we had a system at the highest level of the system, where you get the interfaces between the large subsystems.
Right.
And we ended up with a series of FMEAs there, because I don't want the team to be more than maybe 6, 7 people.
Yeah. Above 10, it becomes a waste of time for most of them.
Yes, exactly. So, well, that was an interesting subject. And so that's how I answered the gentleman who wrote about System FMEA, basically the kind of things we've been talking about. And it was a good question. And if you have any other questions about System FMEA or types of FMEAs, we would love to hear from you.
Or most anything else, too. We might have sparked a couple other ideas or stories or success stories or questions you have on your mind. Let us know. As you know, we always are looking for them. You can go over to accendoreliability.com/go/SOR. There's a couple of ways to leave us notes there. Also, Carl and I and the other hosts of the show are available through LinkedIn and our About pages, and on occasion through our comments on our articles and content on the site. We do get a good number of those too. So lots of ways for you to get in touch. Well, you did a teaser there for that AI one. Should we just kind of, while we're recording, should we just hit record again and talk about
Absolutely
AI a little bit?
All right. Yes, indeed.
Okay. All right, cool. So that's a tease for our next episode, if all goes well. And if you have questions on that, well, you got about 20 seconds to let us know. But in the past, so you need a time machine for that one. But future questions, by all means, let us know. So thanks so much, Carl. We'll talk to you soon.
Talk to you soon, Fred.
Thanks for listening to Speaking of Reliability. We invite you to join the conversation. If you have a question or a topic that you think we should discuss in a future show, please let us know. You can find a comment box below the episode show notes, or just leave a note as part of a review on iTunes.